So we'll make a start. Well, I'd like to welcome everyone to this second in our series of global TAPAS seminars. We
I found this on the web.
We are in the last phase of TAPAS as a project, and we decided that it would be appropriate if we tried to have a more international outlook, and as a consequence, we've commissioned this series of lectures from people from other countries, and it's a great pleasure today to introduce our speaker, Dr. Dong Chun Shin, who is the chair professor of the Department of Preventive Medicine in Yonsei University in Korea, and he's also the director for the national project of school particulate matter and the Center for Energy and Environment Harmonization. So his commitment to environmental health started when he was appointed director of the Institute for Environmental Research at Yonsei University in 1999. Since then, he's been involved in a number of national environmental health action plans, health forums, and professional groups, including the ISES Asian chapter and the International Society for Risk Analysis, and the Asian Regional Seminar on Air Pollution and Risk, and the Korean Society for Green Hospitals. So he seems absolutely an appropriate person to address our audience. As usual, please put your questions in the chat, and I will moderate them at the end. So I'm now going to hand over to Professor Shin. His title for today is School Particulate Matter and the Center for Energy and Environmental Harmonization in Korea. So over to you, Professor Shin.
Thank you, Paul, for your introduction, and thank you for this opportunity. I will share my slides first.
Please.
Yes, it's my pleasure to talk about School Particulate Matter Center for Energy and Environment Harmonization in Korea. I'll start from the introduction of myself. I'm a chair professor at the Department of Preventive Medicine, Yonsei University College of Medicine. I graduated Yonsei University College of Medicine. And my research area is risk assessment and management and health and environmental sustainability. Since 2019, we are funded by Korean government for the national project on fine particulate matter management for school. The project is to identify all characteristics related to particulate matter generation in schools, evaluate and analyze the health impact of particulate matter on students, and demonstrate ways to improve schools' customize their environment, and to implement our research findings into improving relevant laws and institutional system, and to build a big data system. As you all may know, younger children are sensitive to particulate matter. So cleaner and safer school environment is required. And also fine particulate matter has a link to various diseases, not only respiratory disease, but cardiovascular and even neurological disease. For the children, we are quite worried about ADHD. It's attention deficit hyperactivity disorder. And also recently, papers are coming out for the relation to cognitive function. If children are exposed to fine particulate, especially ultrafine particulate from the roadside. And finally, as moderate or enough exercise and activities are very critical to improve their health and growth and development for their age period. So we require to develop an optimal air purification system, taking into account adequate ventilation, temperature, and humidity control. And also our project is based on the use of renewable energy and the improvement of energy consumption efficiency. Our research field comprises 6 main big research areas, from basic research to engineering research and law and some management side with big data. So we start basic research. One is characterization of school indoor particulate matter and emission source verification. And second basic research is for the health impact and intervention effect for the children. And engineering side is development of clean air ventilation system linked with indoor and outdoor heat and air environment with renewable energy. It is implemented for the newly built school. And for the existing schools, the consultation on air environment improvement according to school type and demonstration of customized air environment improvement plan. And as I told you, we have management side research for improving institutional enforcement and big data system for supporting all this system. So I will go in some more detail for each areas. The basic research one is led by Professor Young-Min Cho. He's a professor in Kyunghee University. It's also in Seoul, Korea. He studied in Australia, US, and Singapore for several years. And he's one of the leading scientists in Korea in air environment. His main objectives of research is quantitative evaluation of indoor air pollutants for over 50 schools. In each school, we have 4 sites to measure this quantitative evaluation. So we have 200 site points to measure this. Particulate matter, black carbon, bioaerosols, and VOC and carbon dioxide. And source verification using receptor model or some simulation models of indoor particulate matter originate from outdoors. And identification of chemical physical characteristics of all these PMs. So he samples pollutants indoor-outdoor through national standard method and characterize chemical physical properties. And we have tested chamber, 60 cubic meter test chamber to observe and measure the spatial behavior of PMs. And development of math models to estimate infiltration rate, penetration rate of PMs from outdoor to indoor school, classroom. And assessment of transport model in some community model from outside, wider outside to the school, and using a dynamic simulation and 3-dimensional monitoring we use a sensor network for this and LiDAR technique and so on. And second, basic research is conducted by Professor Chang-Soo Kim. He's a professor in my same department, preventive medicine, Yonsei University. He is evaluating health impact assessment based on periodic medical checkup over 200 students and panel survey. We had some difficulties to conduct this during COVID-19 period, but we gave a great effort and we successfully recruit 220 students, and we check up very thoroughly with questionnaires and physical checkup and chemical analysis of the blood. And also we have personal air monitoring, personal PM monitoring for the students, and questionnaire for psychiatric disease like ADHD and cognitive function, and many things for this medical checkup and questionnaire, and panel survey for 5 years, and personal exposure assessment for 24 years. So including stay home, and stay playing ground, and going to school route, and so on. And we compare before and after intervention. We have intervention for two kinds. One is using application for the mobile phone. We give information for less polluted area route and less polluted area playground, and they are if they are following that message, they can be exposed to less PM for a day. And second one is air purifying device, air purifier. We run a purifier 3 weeks, and then we check some physical change and blood chemistry change, and also cognitive function change. And analysis of health insurance data, we can analyze PM's long and short-term impact and disease treatment effect. So I will pick just one slide for to show you one point of among many results of his research. We make intervention for 3 weeks. During weeks, we have 1 week wash-up period. So it takes 5 weeks in one session. So, and air purifier in classroom, and then before and after, particles exposure is decreased and attention ability is increasing. We have some good results, association between reduction of particle exposure by air purifier in classroom and attention ability. And next is the engineering aspect. It is conducted by Dr. Chun Chang. He's a senior research fellow in Korea Institute of Civil Engineering and Building Technology. He studied and he was a faculty member of Kyushu University in Japan. His major research objectives are achieving over 30% of renewable energy usage on newly built school, and keeping fine particulate matter concentration level well below WHO standards, and noise level with less than 45. It's not easy to make 45. However, we have good HVAC with filtration system, so we did. we have about 38 or 39. So people really like it, yeah. And keeping hybrid filter pressure. So we achieve a very low level of pressure loss, yeah, with the hybrid filter. Hybrid filter is we use electrostatic filter and also fiber filter get together. So we call it hybrid filter. So it makes us some less pressure drop. And achieving top level of energy efficiency. And then we make this system, and then we will implement in the real situation on 2 schools with some very strict specification. So, and as you see the last line of this slides, also we standardize the clean ventilation system performance in Korea with this project. So I will show you a couple of point out the interesting point among many results. We have new concept for return air site, return air height. So optimal design of the return diffuser position. So as you can see, if we put return air point, flow air return, the air mixing is complete, more complete than upper return. So in flow air return, air supply can reach to the classroom floor sufficiently and uniformly distribute. And with this flow air return, we can get 35% faster, yeah, compared to the upper air return to get the level of good air quality, particulate matter level. So it's very interesting, and we published this in some paper. And among our many results, you can find good papers in articles in relevant journals, from basic research to engineering research. And we get noise level below 40 decibel. And so you are seeing mock-up. Actually, mock-up of our test bed is mock-up. We make 2 classrooms, mock-up classrooms, and we test all things here. So we have we can get data, and we can get optimal conditions, temperature, air environment, particulate matter, and many things too. And then we will move to actual school with this preparation data. So we have step-by-step implementation, and we can get thorough actual data, and we are very ready to expand our results to our other situations in our country. And another engineering big research is for the existing schools. We have many existing schools, over 12,000 to 15,000 is depending on the counting method. And classroom is about 300,000 classrooms in existing school. So it's very important to make some consultation, procedure standardization, and actual improvement demonstration and cost-benefit ratio for that improvement. So this project is done by Tae-young Kim, professor in also Yonsei University, Department of Architectural Engineering. He studied in Tokyo University and also is now take up very important roles in Korea. And their objectives are development of SOP for consulting air environment for the school and development of a comprehensive diagnosis system based on the numerical analysis and analyzing and consulting air environment on 10 places of existing schools. 100 places. So they measure school by school, depending on the pollution type and old school and new school, old school and relatively new schools and various types, and actual improvement is for the 50 places, 50 sites. So 100 places for the diagnosis and 50 places for the treatment, and compare. And we can compare cost and benefit, and we can make SOP for various types of schools in existing school. And also establishment of operation of 5 IoT-based living lab for existing school. And they are running 24 hours for 5 years. So they produce lots of data. And building a database based on results of consulting, demonstration, and operating of living labs. So their key research keywords are comprehensive diagnosis system and standardization of consulting process, and they demonstrate actual improvement. And IoT, with IoT, they are running a living lab. So they have their own school air portal site with the contents of description of diagnosis and improvement method, and indoor air quality diagnosis tool, and real-time guide to operating air purifiers throughout Korea, and so on. So, and they also they will publish handbook for including all things there, and this will be distributed to all school teachers and relevant peoples there. And this handbook includes all things already I mentioned. And this this research is for the low-end institution. Actually, it is a management plan from the government and from the educational district. So this is done by Young-wook Lim. He is an experienced a scholar in Korean management system. So he is main objectives is revision of School Health Act and related system, and setting a standard for accreditation of school type air purification system, and development of school PM managing tool is a toolkit and PM educational programs. And last research areas, big data and AI system, is conducted by Professor Jae-hyun Kim, Department of Computing Engineering, Seoul University. He developed techniques for big data collection, processing, and analysis. So his research objectives is establishment of energy environment linked fine dust big data solution, and developing the AI-based school customized energy environment linked particulate matter management and integrated support system. And he will already develop e-coding books and big data of school customized area environment already to prepare for the smart service application. So I will wrap up. As you know, fine particulate matter in Korea was a public health crisis, and still I think the public health crisis, and will be more in the near future, I guess. Before COVID-19, from year 2014 to 2019, for about 5 years, we experienced really crisis, really disastrous particulate matter pollution, including Seoul. So people's concern was very high, and government denounced its disaster. And then Korean government make many various plans to combat this PM issue. So it was successful for a couple of years. And then COVID-19 was coming from 2020 to 2023. For 2 or 3 years, the PM level was coming down. However, even during that period, the level was higher than Korean standards, and more than 3 times higher than WHO PM 2.5 standards, annual standards. You know, WHO strengthened PM 2.5 annual standards from 10 to 5 microgram per cubic meter in 2021. However, now Korea is about 18 to 20. Before COVID, it was 26, 7, or 8. So now the PM issue is now come again. So it is slowly increasing pattern. So we have to prepare to make more reduction in particulate matter. And another big issue is recently the health effect from the particulate matter is wide and various, from respiratory, cardiovascular, neurological disease, Alzheimer's disease, and attention deficit hyperactivity disorder for the children. Is not only the early excess deaths, but various kinds of morbidity. So it is, I think it is in Korea, it is one of the top public health issue in the future also. So children are most vulnerable group. So it is very important to protect our young students' health through effective measure against fine particulate matter. So we have been conducting convergence on engineering technology and public health to reduce fine particulate matter in school. And we need to discuss on future research direction for safe school environment. And also we need exchange of latest knowledge and mutual cooperation in regard to healthier air for healthy school, to make clean school environment by raising public awareness of particulate matter in school and continuously reflecting schools' feedback for the improvement. Thank you very much.
Sorry, I'm muted. Thank you very much, Professor Shin. That was an excellent summary of what is going on in Korea, and it's very encouraging that you've taken such a holistic view about this. I think it's remarkable, really, that you go from basic research right through to legal matters and implementation in the way that you described. So I think that's really excellent. So we have I think so far only one comment in the chat, which I'll pass on. And I don't know who it's from, but it says emission source identification should be the first action, I think, for PM mitigation. And I guess the question is, do you agree with that identifying sources is the critical feature here?
Yeah, I agree. It's emission source should be managed and controlled to cut down the ultimate PM in school inside, and also and classroom as well. So yeah, that's most important.
And I presume it's much more, it's an urban problem mainly, or not? Is it throughout the country?
Mostly urban problem.
Yeah, associated
and we conducted mostly urban roadside schools.
Right. I would just encourage others, if you either want to put something in the chat or raise your hand, we can take a call. I have a question of my own, which is, you mentioned ADHD a couple of times, and I wonder what's the evidence that this is related to particulate matter?
Particulate matter, especially the fine, ultra fine ones,
right,
can transport from the nose to the brain by the cellular translocation. So the academias have that evidence a lot. And also, if inflammatory changes in deep lungs or bloodstreams, and they can make cytokines, and that cytokine is moving to the brain circulation.
right.
And if the brain is started to make inflammation, the brain vasculature, brain blood vessel endothelium is loosening, and then fine particulate can enter with that pore or loosening. And cytokine itself also trigger inflammation in the brain. So brain cells is inflamed. And we have some pathological finding to see the inflammatory cells are in brain cell region. So, and there is a toxicology, biological phenomenon. And we have one big research from Harvard School of Public Health done by Joel Schwartz, and they analyze huge data, and they strongly suggest Alzheimer and Parkinson's disease are related to PM in United States people. And also, we have some paper. I read some paper from European countries. PM is related to ADHD.
Okay.
And also, one big research from Jordi Sonia in Barcelona is a EU Center for School Health due to particulate matter. He published 2015 or so, and near traffic schools, students are less cognitive function compared to non-traffic regions.
Okay.
It's very worrisome and very important.
Yes. So Patricia, you have a question in the chat, but you're online. Would you like to speak it out? Say it.
Sure. Hi, thank you for your talk. Really interesting work everybody's doing. My question was around standards, actually, and the fact that there's a lack of indoor standards in general, and then for schools more specifically. So curious if your center, if that's part of one of the goals, is to create new indoor air quality standards for PM, for particulate matter. And then if you are, then what is it that you're going to be doing? Because it's hard, right? Against what outcome, against what levels, what kind of PM, what size range? So can you talk a bit about that?
Yes, that's a good question. Yeah, we do have indoor air quality PM standards in Korea for the general building. And we do have classroom indoor PM standards. It was set a few years ago when there were high level of PM in Korea. So we have school classroom standard is a little bit more stringent compared to the general building. It is about 35 microgram per cubic meter per day. However, we do not think it is enough to protect our children. So our research is now going on to seek the optimal level, considering health effects and some feasibility, technical, and some budgetary feasibility, and so on. So we'll make some common ground, and we'll propose this to the government to make a new, more stringent, stronger stronger standard, compared to existing one. So we can make some data, present data, what's going on if we make this level, and we can meet what percentages can be met if we make this level. So we'll analyze Korean existing data in many ways to see the optimal points for new standards. So it is one of the big job for us. Yeah.
Maybe a follow-up on that, because you were just talking about ultrafine particles. So is that a new standard for PM 2.5 or for ultrafine particles?
No ultrafine. It's a PM 2.5.
PM 2.5.
Yeah.
Okay. And then on the outcome side, sort of picking what as an outcome, health outcome or learning outcome, to make a decision for a new standard.
Yeah, well, we have a concept for that system for making new standards. However, we do not have real epidemiologic data to support this. So we are now analyzing WHO recommendation and the WHO's primary data and compare this to Korean exposure and monitoring data. Yes.
Thank you.
Thank you.
Does anybody else have any other questions? If they'd like to, they could unmute themselves and ask directly. if not, I have a question kind of around the big data issue and sort of working with schools. It seems certainly in the UK that one of the issues we face with working with schools is that teachers are very busy people, and getting them to participate in what seem to be even quite simple tasks of setting up a CO2 monitor or so forth is actually quite a big challenge. And I just wonder how you're going about collecting data from a significant number of schools and working with them. How do you work with schools in general?
Yes, we will make big data system with two approaches. One approach is we will pile up all the data from our project, our own project. We have many, we can generate many data, lots of data for our from our own project.
Right.
And second is we will collect data, existing data in Korea, all the PM measurement data, and make a basic roadway to fill up in the future. Yes, so we can make a system to gather future generating data in Korea. And another one is we are now making some predicting models.
Okay.
You know, we have monitoring sites in Korea, many monitoring sites in Korea, and also Korean telecommunication KT company is now running monitoring sites, lots of monitoring sites in Korea. So we'll utilize this monitoring site data, and we can make some simulation to predict concentration near schools near monitoring sites. So it's a simulation methods to get data. If it is validated, we can have hourly data. Yeah.
Yeah.
In school.
Okay, thank you. I don't see any more questions in the chat. So what I do see on this particular call is a number of people who are, I think, from your part of the world in Korea. So we're very pleased to have you listening in to this talk. And please, if you would like to get more information about what we're doing here in the UK, please get in touch with Kat, our network manager, and she can put you on our mailing list for our newsletter. And this talk, along with others, are on our website. So please do that. It's really important for us that we do collaborate, I think, across the world as much as possible and learn from each other. And so I'd just like to encourage those of you who don't normally attend these meetings. If you'd like to continue, we'd be very happy to have you along and to join our network. Kat's put that information in the chat, so you can find the information there about how to do that. I'd like to finish by thanking Professor Shin for giving up his evening to bring us this seminar. It's been very interesting to learn what's going on in Korea, and I think I'd like to sort of personally congratulate you for your activities. It seems very well integrated and organized, and probably slightly envious of the way that you've put all this together. So it's really excellent. So thank you very much for a very interesting talk. We appreciate it very much. Just to tell everyone that there is no seminar next Monday because of various school holidays here, but please join us on Monday, the 6th of November at 1 o'clock and we'll hear Stefan Flagner from the Netherlands talk on is indoor air quality in classrooms related to sickness, absence, and test performance of elementary school children, which I think is an interesting question. I'm interested to know what the answer is. So thank you all for attending, and have a good week, and we'll see you in 2 weeks from today at 1 o'clock. Thanks very much. So goodbye.
Thank you. Goodbye.
Goodbye.